Topic of this video and associated handout is the use of the Wiley libraries and other specialty libraries with the NIST 26 search. And I'll be particularly talking about the Wiley 26 and why settings matter. Wiley libraries include many partial literature spectra, and NIST 26 requires specific settings to correctly handle and match partial spectra, unlocking their full potential. I have employed the Wiley registry since 1990 in support of R&D and chemical manufacturing. It is a very useful resource when used in combination with the NIST libraries. Many spectra in the Wiley are not found in the NIST libraries and vice versa. However, many partial spectra in Wiley from literature sources require special settings within the NIST 26 for optimum results. NIST are almost totally complete EI spectra, and more details are shown below for the Wiley partial spectra. Here is some detailed information about the NIST and Wiley registry libraries. The NIST has both a main lib and a rep lib, and it's a very good high quality library for both, but the main lib only contains one spectrum for each structure, and it's somewhat subjective, so it might not always be the best spectrum. So I like to search both the main lib and rep lib when doing my work. The Wiley main complements the NIST 26 to increase compound coverage. It also has replicates, and occasionally I will use the Wiley low quality if I want to extend the coverage to its maximum. But the Wiley legacy is historical searches and confirmation of older work. It's things that have been taken out. If you wanted to see why it's been taken out, or if it's in that library, you can look there, but I never use it for searching. And I have some recommendations again for bottom that kind of echo what I said above about which ones I choose, and I'll show that in the video also. This slide shows the growth of the Wiley registry versus the NIST EI mass spectral library over the years since the inception of the NIST library. You can see since 2010 to 2026, there's been very significant increases in the number of entries. This slide shows the growth of both the entries, the number of entries, but also shows the number of unique compounds that have been added over the years. I showed you these two slides because you might consider purchasing newer copies of the libraries, especially since they've increased so much in actually quality and quantity over the last few years. You can get a combined version of the Wiley Registry NIST libraries is available, but I suggest separate standalone versions when used with the NIST 26. It's easier to determine the origin the library hit in the NIST software, and in some cases you might want to limit the use of the Wiley because it has some partial spectra in the search. That is, those acquired over a limited mass to charge range, and most of those came from the literature. However, the combined version could be optimal if you're used with certain vendor search software. But if you decide to buy the NIST 26, please shop around. Prices can vary dramatically. I don't know as much about the Wiley library and prices, but also for both of them, consider upgrading a previous version of either the NIST or the Wiley because it significantly reduces the purchase price of both. There's also user libraries, and I've always created user libraries. Even though they're smaller, they have things that are very important to you, and I have a section, part 5, on my website in the NIST 2026 tutorials that shows you how to create your own. Wiley also has many specialty libraries that are available at Scientific Instrument Services and other places, and I show them below. This slide gives you an idea of how many entries are in these specialty libraries and what they are. Again, the NIST does have a combined library, and if you want to buy it, I suggest you buy those separately. But you might find these other libraries very useful to you depending on the type of research that you are doing. On my website, in the 2026 resources, there's some information about the source codes, and they're found in the 2020 and 2023 Wiley libraries. The 2026 manual on their website did not include. And these source codes just kind of give you an idea of where it came from. If you wanted to, you could go look up the reference yourself and see how it applied to your work. So I found this very useful over the years. The other topics here I'll demonstrate in the video, and I won't step through them, but I think it's very much more useful to do a demonstration as opposed to talking about them in a handout. I first want to discuss the use of the different libraries within the chromatogram tab, which is a new part of the NIST26 software that allows deconvolution and library searching. So we go up to File to analyze the EI file, and I've selected this Grove file shown here, and I will go to the libraries, and here you can pick whichever ones you want. This search only gives the best hit for the library search and deconvolution. So I've been mainly just using the main lib for it and not these and the rep lib and not using these additional ones. That I'm not really sure if they will matter with regards to the final searches, but these do have the partial spectrum, and I'm not quite sure yet which way is the best way to do it. So try it in your work and see which works for you. You can search as many libraries as you want to, but in this case, if you search them all, it'd be over 1.3 million. So I think we'll just get rid of these for right now and search those and say, okay. And it'll go through the search and show you the results. And you can see here, I did like having the library here because I like to see which library I searched. So if you had the combined library, you would not be able to do that. Now we need to set up the settings within the library in other places. So we'll go to the chromatogram below and we'll pick this peak here. And I'll right click on it and say send to libsearch. Now you can see at the bottom, we're in the lib search now. The big difference here is that besides in the chromatogram tab, you only get the best hit only. Here you get all of the hits ranked by the match factors. So if you want to consider other possible structures for something, then you need to go into this. So it's a more complete type search. So we need to set up the settings here also. So come up here to where we say library search set options. I'm hovering over it. You can see it at the top. And now we'll set up our search. We're going to do an EI normal identity search, full spectrum search in this case, default pre-search. That's good. Libraries. I'm using the shift key on my keypad. I left click on the first entry. I hold down the shift key, go to the bottom. I just want to get rid of all of them to show you how I bring them in. So the main rep lib, I use the shift key to select two of them, add those. You can see we're up to about 431,000 entries. We will not pick the legacy as we talked about in the handout. We'll pick the low quality just to get the maximum number of things to consider, and the main and the rep, using the shift key again to hold while I've selected them all, and then add them. All right, so that's good there. You can see we get over 1.3 million, but you can see this is for the spectrum search here. We will be doing structure searches, so I want to show you how to set those up while I'm here. And we'll go to structure search. I'll get rid of all of those again, talk about bringing them in. The main lib, when you bring it in, it gets the rep lib automatically for structures. I'll hold the shift key to select the low quality, the main, and the rep, and then add those. And we're up to over 1.2 million structures to search and say, okay, so everything's set up now. After you get things set up, you might want to save the configuration by coming up here and say save configuration. Then you can give it a name. I have mine JL_default. And that way, when you come in, if you change something and you want to go back to the original settings that you had, this saves all the settings within the chromatogram window, libsearch, and other places within the program as far as Windows setups, etc. So it's good to save your configuration. There's one last thing I didn't change that I want to show you. I'm back up here to the library search options. This is somewhat optional, but I think it helps in a lot of the searches. Usually the limits. If you come in, the default will be off. And so if you change this equals to 10, this helps get rid of some of the partial spectra that might come to the top to be shown in the top results that really you don't want there. So it's not a bad thing to save that with equal to 10, and you can that's the main thing you need to change. Just change that and say, okay. And then again, save it in your configuration if you wanted to. But now I'll select this just to do a search for the new settings. You'll see I'm going down to the bottom here and looking at the results. And I'm using the the arrows on my keypad to step through them. Step through them, you'll see a lot of the same structures. And so if you wanted to get to the next thing to consider down in this part of the list, you'd have to step through all of those. But there is an option within the NIST software. If you look up here, this little best matching only, I'm hovering over this, click that on. Now I go to the bottom, I use my arrow keys, and you can see the next thing is a different structure. So that's a good way to not have to look at the same thing over and over again while you're reviewing your results. So be sure to be cognizant that you have this on or off. It's really hard to tell by looking at it, but look at the number of entries. When it's off, I get 100 spectra in the search results. I turn it on, it gets rid of those duplicates and brings it down to 30. So that's a very handy option if used properly. Here's a tip to more effectively use these Wiley partial spectra for your NIST searches. So let's come up here to where it says Library Search Options, and we'll pick that. And instead of the standard search where we use the full spectrum, that's the normal, we're going to switch to impurity tolerant reverse dot. So in that case, it used to be called the reverse search, but they changed the name here, but it's still the same thing if you used it in the past, and select that instead of the standard one we would use and say OK. The other thing you need to do when doing this is come up to these properties that you display and right click on that and go to properties and come down to where it says reverse match and say OK. Now you'll see you have another column here. So now you're set up to do the search. So when you search it now, we'll do a go. What this does for you, if you had a full spectrum up here that you obtained on your instrument and you wanted to see if it was in the library, but you didn't have any results using our standard approach, which you should always use first, then you might want to try this because it does a better job of getting these literature spectra, these partial spectra, to come to the top of the search list. And how does it do that? Well, if it has extra peaks in the top, which would be your full spectrum, but the partial spectrum's missing those, it does not penalize the search results for that, such that the ones that have these partial spectra will come higher on the list. And they'll be shown by reverse match over here. So you need to look at the reverse match column when you do that, when you do the search, and you'll get a better chance of getting these and getting results that you would have not have gotten with the standard search. But again, use the standard search first, but use this additional approach when you think you want to go into it a little deeper and maybe find some partial spectra that would be useful to you. The other thing you can do to do these partial searches is to specify the molecular weight here. So you could say, in this case, I know it weighs 220. I want to look for the partial spectra, so I want to do the impurity tolerant, so I'll do both of them, and that'll only find things that weigh 220, so it'll be even more specific. So I hope you find this useful in maybe making better use of these partial spectra. I have found it very useful in my work, but I'll switch it back. Since I said normally we don't use that, we'd go to the full spectrum search, don't specify the molecular weight. It doesn't hurt if you leave the reverse match in the column. When you do the standard search, you'll compare things by match. You do the reverse search, you look at things by reverse match, and you can sort these if you want to by clicking on them. I mentioned that you could just resort by reverse match by clicking on it when you do a standard search. So normally it would come up with match. But if you wanted to just see the partial spectra by clicking on that, that would be a little bit misleading, and I will show you why. If you come up to the menu again, let's say we did a full spectrum search. The problem is if you did this default search here, it might filter out a lot of the bad spectra or ones that we don't want to come to the top normally for a standard search. And that's a good thing. It makes the searches go faster by when it gets through. It has this pre-defined list that it can do a very detailed search to get the final score. But if you're doing this partial, that might be a problem. We said one way to get around it is to click on the molecular weight if you know what it is. But if you didn't, might be better just to turn the pre-search off so it just goes away. So you'd come up and say impurity tolerant search and turn either the molecular weight on or turn the default pre-search off. So that's another way to somehow bring these better partial spectra up to the top where they might be useful to you. So let's put it back like it was so we don't do this by mistake. So we'll turn it back to full spectrum. Default pre-search is once again on, and it's back to doing the standard search. Told you I like to have libraries shown, and when it comes up with the software, it might have this not showing the whole display. So that's why I like to have the separate libraries. I like to see them. But you can see even though I'm stretching it with the left mouse button, still not seeing the whole library. So it's a little bit misleading. So we'll right click in this box and go to Properties. And we'll go up to Spec List. And instead of having short library name picked, we will turn this into all. Now we display it, we'll see the whole name over there. The other thing you might want to do, clear history on exit. That's a nice option because it creates all these small results files that stores on your computer. They never go away till you delete them. But if you do this, it'll automatically clean up for you when you're through. And the other thing's the plot on hit when it comes up. I have mine with the structure here, but I think the default with structure on plot is not selected. So if you like that, be sure to click that. So now we'll hit OK. And you'll see now, I still didn't get it up, did I? Need to go back, right click, properties, didn't get it selected right. I don't want the short library name, I want the long one. So do it again and say OK. And now when you come up, when you stretch it out, you'll see the long name so you can tell which library it came from. And the other thing I was talking about was the spec hit up here, like clear history. You can clear the history if you want to by getting rid of those. But it shows the histories here of all your searches that you have will be there. It's such a fast search, I usually don't bother looking at those, but that's where these extra hits are being stored that creates these small files. So I hope these extra tips were useful. To now, we've only talked about searching the database by spectrum, but you can also search all of the databases by structure, even for these partial spectrum that you might have in the Wiley library. So first you have to make sure you're setting proper libraries to be searched. So you come up to your library search options. You come down to not the spectrum search, but the structure search, and you pick the ones you want. I've got the main lib, which includes the rep lib, and then we have the low quality and the main and the rep for Wiley. That's all set up. We come over. And what can you search? Well, you can search anything that has a structure. So we might have something we imported from ChemSketch here that I want to see on model compounds for to see how they fragment. Or you can pick something that has a structure and a spectrum. Doesn't matter, but let's pick the one with the structure only. We come up to the little part up here where it says structure search and click on it and search it. And you'll see that the ones are listed in the bottom, and you can step through them with the arrow keys on your keypad. It starts at 1,000, which is a perfect fit, and comes on down, and you'll find model compounds. You get lower and lower numbers. You can also use the best hit here if you don't want to see the same thing over again. See, we have 189 spectra. If you look at the top here, you click on the best matching only, it'll go to 400. So I had that on, so I was getting rid of some of the duplicates there. But you can take advantage of that option here also. So that's that part. If you want to search, that's by similar structure. If you want to search by exact structure, you pick something that has a structure again. You come up to the settings here and you go to search. And instead of having Inchy key on, Inchy key is a representation of an ASCII representation of a structure that NIST uses to search things. And so you need to pick that. Usually you have that off. So if you turn that on, be sure to turn it off when you get through and say, OK. And you can see the Inchy key up here that represents the structure if you look up at the top. And it will search those. But now instead of pushing the button that says structure search, you have to use the one that does a library search. It's just different. A little bit misleading there, but remember that. If you don't want to do an exact search, then don't push this, have Inchy key selected and push go. And now you'll find the structures that are exact. So everything in the list should be for the hydroxy species shown at the top. for all of them. So that's the way you find the exact searches. And that way it might find things with deuterium on it also, but besides that, it'll be the exact. So this one with Inchy key selected for exact searches. This one with no Inchy keys selected for similar compounds. For finding models, the similar is very good. But remember, when you get through with that, turn it off. You'll start to do some other searches and you won't get the right results. And say, okay. So let's talk about one last thing. User libraries. So when you create a library, you can add things to a library. You come up here and you say, add to your library. And it brings up whatever library you want to add. Or if it's a new library, you've never had a user library before, you put your own name there. And that's in my tutorial series in 2026 tutorials. So take a look at that. I don't want to go in that in detail there here in particular. But after, let's say you had 100 entries in your library, you added, this is 101 now. And so you want to use that library. Well, there's no problem in using that library in certain things. It's no problem in using it when you do hybrid searches or things related to Inchy keys, etc. There is a problem when you want to search by structure. After you add something to a library and you want to search that library by structure, it will not search, but the first 100 entries in this case, the 101st will not be done because you haven't updated the index. And to do that, you come into the lib search window, click it at the bottom, up to the top, and you'd say rebuild structure search databases, and it'll bring up a window. It brought it up on my other terminal. I'm bringing it over here. And usually it'll be in lowercase if it needs to be updated. And you just say build, and it did it. And you'll notice now it's in uppercase. That means that the structure index is up to date and can be searched by structure. So when you add things to your user library, remember to do that, or you won't be able to search your most current entries by structure until you do that, rebuilding that index. One other thing, if you have older copies of the NIST library, or you have older copies of the Wiley library or other libraries, and you're not sure if they're quite indexed properly, it's always not a bad thing if you're having problems with them to rebuild their structure search databases, that index. And hybrid search is another good one to rebuild. The other one is index Inchy key. Those are the three that I usually look at if I'm having problems. Usually the structure for the newer version of the NIST26 is the only thing you have to update. But if you have older libraries or if you're having a problem, don't forget this tool because this will fix a lot of problems by fixing those search indices. So I hope you've enjoyed the video. I hope you find it useful. Good day.